Hello, boys and girls. Hello, my sailors. I hope you guys are doing well. Please let me know. Am I audible? Am I visible in the chat box? Please let me know. I hope we are doing well. A very good evening to all of you. A very good evening. All right, just making sure. Yes, so all my sailors, I am visible, I am audible. Please let me know in the chat box. Hi everyone. Yes, a very good evening to all of you. Today we are starting a new chapter, Surface Chemistry, and we will talk about adsorption today. We are going to talk about this in today's session. All right, तो आज नया chapter start कर रहे हैं, right? All right, everyone is yes, fair enough. All right. So without wasting any time, let me introduce myself first. If you are coming here for the very first time, my name is Harsh Maheshwari. I am an alumnus of NIT Warangal, and yes, I believe in one thing: जो करो मजे से करो, ठीक है? When you will be happy in doing what you are doing, right? Success will automatically come. And similarly, boys and girls, I will let you know I'm demanding from each and everyone this particular thing I'm going to say. Subscribe to our channel and definitely make sure you hit the bell icon so you would be notified when we are coming lives, right? So you will be knowing when your favorite teacher is coming online and your favorite teacher is me. All right, so do make sure that you subscribe to our channel. ठीक है, जरूर subscribe करो, बहुत अच्छी चीज़ है. और एक और चीज़ जो बहुत important है, one very good announcement for you guys. If you are weak at any topic of 11th standard and 12th standard also, you feel like you want to check it out again, all our micro courses right now, we are, there is like a flat discount and you will be getting any kind of micro course on any topic, whether it is physics, whether it is chemistry, whether it is maths, just by paying $1, right? $1, and it's very cheap. So definitely आपको मान लीजिए ionic equilibrium नहीं आता, you don't know ionic equilibrium, pay ₹1 and enroll to the session, enroll to that particular session, and you can learn ionic equilibrium for free. ठीक है, free बराबर है. So make sure you get the advantage of this particular micro course. Link is in the description box. If you lag or you don't know any particular topic of 11th class, do make sure you buy the micro course and learn from us. ठीक है, description box में, in the description box you will see the link to it. Let's come to today's session. Let's, without wasting any time, I will talk about today adsorption and absorption. What is the difference between them and why we are reading it? What is the use of it? सब समझेंगे आज के सेशन पे. So let's start with it. Let's start this particular session. Surface chemistry, the name of the topic. What is surface chemistry? From the name itself, it is quite clear. We will talk about something which is happening at the surface, right? Adsorption happens at the surface of the compound, right? Adsorption is nothing but a surface phenomenon, right? Surface chemistry is whenever a gas gets adsorbed on the surface of a solid, on the surface, then we call as adsorption. And the chemistry which talks about the surface is called as surface chemistry, the branch of chemistry which deals with the study of the phenomenon occurring at the surface or the interface, sorry, never at the bulk. We'll not talk about the bulk. We'll only talk about the surface. So when some gas molecules gets attached to the surface of the particular solid, right, or a liquid also, right, whenever it is happening only at the surface, we will talk. It means automatically we are learning about surface chemistry. So what we are going to study here today is adsorption. In adsorption, boys and girls, what happens? Best example, some gas molecule. मान लीजिए this is your substance, right? This is your substance, right? Some gas molecules were there outside. They saw this substance and got attached to it, right? They saw this substance and they got attached to it, but only at the surface. This phenomenon would be called as adsorption, right? I give you a simple example. Have you seen in movies? You might have seen some gas mask. You have seen workers actually use it. The mine workers actually use it. You might have seen Or have you bought some new electronic item recently? Have you seen it? Have you seen that they are giving some silica, packed silica in that particular electronic item? If you have bought some medicines, expensive ones, right? Fish oil, have you seen fish oil? If you will buy it, they'll add some, silica gel to it. Have you seen it? Some pouch of silica gel. किसी ने देखा है? You might have noticed it in various places, but you don't know exactly what it is. क्या आपने देखा है? Silica packets added to your electronic items. Similarly, gas masks. Have you seen? Yes, this is a new lesson. Have you seen gas masks? आपने देखे हैं? Let me know in the chat box. बहुत बढ़िया. ठीक है? So that's the thing. So whenever something is happening at the surface, boys and girls, you call it as surface phenomenon. And adsorption, what is adsorption? When some gas particles get absorbed at the surface, never in the bulk, only at the surface, is called as adsorption. It is called as adsorption. Accumulation of molecular species only at the surface. Best example I have given you, gas masks. The workers use it in mines to stop the inhalation of some poisonous gas like carbon monoxide, sulfur dioxide. They use that. Gas mask contains activated charcoal. It will only adsorb. It will only adsorb, sulfur dioxide or carbon monoxide. It will pass the oxygen gas. So it is just at the surface. Best example, silica gel. Silica gel is used to adsorb the moisture. On the surface of the silica gel, water molecules will come and adsorb, and your electronic items would be free of any kind of moisture. ठीक है? This is the way we do it. सबको समझ आया? सबको clear हुआ? What is adsorption? It is happening at the surface rather than the bulk. अच्छा. Now how do I differentiate it with absorption? बेटा, in absorption, have you seen a sponge? आपने क्या sponge देखा है? Let me differentiate it right here and now. Have you seen a sponge? If you take a sponge and dissolve or dip it in water, water gets dipped into it also. Water gets actually, it seeps through in. पानी अंदर तक चला जाता है. Have you noticed it? The water seeps right into it. It means it is a bulk phenomenon. Water can enter inside. But when water would be only coming at the surface, we call that as adsorption. I hope it is clear. Example, silica gel can adsorb the water molecules at the surface of it. I hope it is clear. सबको समझ आ गया? So adsorption is a surface phenomenon, whereas absorption is a bulk phenomenon. Adsorption, D आता है यहाँ पर. ठीक है? There is adsorption. This is the way we will remember. I hope you are all getting it. It is a surface phenomenon. ठीक है? Examples, charcoal, you can see on your screen, beta. I have taken some example as well. Charcoal, liquid can also adsorb some gases on it. Liquid can also adsorb some gases on it. I hope you like the examples also. Animated examples I have given here right now in front of you. It is only happening at the surface. ठीक है? बढ़िया. अच्छा. Now, why this adsorption is happening in first place? We'll think about it. Let me tell you. Beta, if I talk about any substance, मान लो, right now, the screen you are looking at, that is our substance, right? It has some molecules inside. The molecule which is inside, it has force coming from all the directions. So net force is 0. But imagine some particle is at the surface. Some particle is at the surface. If you notice, the particle will have an inward pull, right? The particle will have an inward pull for the gas molecules which are moving outside. If this is your gas can be attracted by this inward pull, because the particles which are at the surface, they have a force which wants the gas to come and sit at the surface. This attractive force would be seen by the gas and will get attached at the surface. So why it is happening? Because your substance has many particles in it. The particles which are inside, nothing will happen because of it. The particles which are at the surface, they have an inward pull, because a particle will experience force, from all the direction. A particle experience forces from all the direction. But if I talk about a surface particle, which is the particle which is at the surface, it will only have an inward pull, right? So it will pull the electrons in. I'm so sorry. It will pull the gas towards it, and you will get the adsorption. So because of the inward pull of the particles present at the surface, adsorption takes place. Okay? I hope my point is loud and clear, and you guys are understanding. ठीक है अच्छा it's a humble request stop अभी right now I am teaching so stop talking in the chat box let's be oriented let's be focused है ना it's a humble request ठीक है all right moving on so some examples adsorption of moisture of silica gel decolorization of sugar by charcoal surface your sugar which you eat white color sugar you see in your households actually it is not it is the sugar contains impurities it is brown in color when you process it when you purify that color you use charcoal will absorb all the impurities and you will get a crystalline form which is white in color which you see right that's the reason adsorption of dangerous gases by gas mask what are the dangerous gases carbon monoxide sulfur dioxide that's why mine workers wear this gas mask okay all right moving on so what is the difference I have just now explained one by one आपको पूरा explain किया है adsorption if I talk about it is a surface phenomenon right and if I talk about absorption it is a bulk phenomenon surface phenomenon easiest way you can remember sponge you dip it in water entire sponge would be wet if I take silica put it somewhere in this room silica will absorb all the moisture on its surface inside it will be okay there will be no water molecule only at the surface right I hope everyone is understanding Gaurav beta stop spamming it's not nice right it's not nice okay all right is there some way is there everyone is understanding right adsorption is a surface phenomenon absorption is a bulk phenomenon है ना बढ़िया समझ आ गया एब और एड एक में ए बी आता है एक में ए डी आता है दैट्स द डिफरेंस राइट बहुत बढ़िया काफी बढ़िया चलो आगे बढ़ेंगे नाउ adsorption contains basically it is because of two things adsorbent the surface on which the gas gets absorbed is called as adsorbent काफी irony है जरा ध्यान से सुनना pay full attention it's ironical the surface at which the gas gets adsorbed is called as adsorbent the gas which gets adsorbed is called as adsorbate ironical huh understood clear the surface at which the gas gets adsorbed is called as adsorbent and this gas which is getting absorbed is called as adsorbate ये याद रखना ठीक है थोड़ा सा ironic है आगे बढ़ेंगे now what is extent of adsorption extent of adsorption is x by m where x is the amount of adsorbate means how much gas is getting adsorbed at the surface m is the mass of the substance on which the gas is getting adsorbed right m is the mass of the substance if this is your substance the mass of this substance is called as m and whatever the gas is getting deposited is called as x okay and it is quite clear if x is more x by m is more means extent of adsorption is more it means more gas is coming and sitting at the surface of the particular substance ठीक है I hope it is clear सबको समझ आ गया है सबको क्लियर हुआ बेटा बातें समझ आ गई है yes आगे बढ़ता हूँ अब आगे बढ़ता हूँ now what are the factors affecting adsorption first factor nature of adsorbate means the gas which is getting adsorbed वो कैसी है right how it is hydrogen gas likes to get deposited at platinum surface rather than iron surface अच्छा the points I am going to say na point number 1 and point number 2 kind of are same only pay full attention adsorbate a particular gas is getting adsorbed at a particular surface and it wants a particular kind of surface. For example, platinum cannot absorb hydrogen gas, right? It cannot absorb hydrogen gas. Whereas if I talk about, I said wrong. Platinum can absorb hydrogen gas, but iron cannot absorb the hydrogen gas, right? So hydrogen is not adsorbed by iron. So you must be knowing what kind of gas gets deposited on iron, right? On the surface of it. Nature of adsorbent. Nature of adsorbent means, for example, charcoal. Charcoal can adsorb sulfur dioxide but not oxygen. It can adsorb sulfur dioxide but not oxygen. So as per your adsorbate and adsorbent will change, their requirements will also change. These 2 points are interrelated. These 2 points are interrelated. If you have a particular adsorbate, if you have a particular type of gas which gets deposited at the surface, it will prefer a particular surface. For example, hydrogen gas is more preferably deposited at the platinum surface than iron. Similarly, if I talk about my activated charcoal on which the gas will get deposited, or it will get at the, will come and sit at the surface, it likes to have a sulfur dioxide gas rather than oxygen gas. So some points we have to learn, we have to understand these two are interrelated. All right, आगे बढ़ता हूँ. Pay full attention. Now the points will become more interesting. Surface area. This is a very important point. Catalyst helps increasing the rate of the reaction. It helps in the it helps in increasing the rate of the reaction. So catalyst, what we do, we actually take powdered form of catalyst. If we take powdered form, surface area will become more. So more gas can come and sit at the catalyst, surface of the catalyst, and give product, right? Basically, how does catalysis happen? You take catalyst in the form of powder. Powder means more surface area, so more gas can come, more reactants can come and sit at the surface of the catalyst. They will give reaction, and then product would be formed, which will be detached from the catalyst, and you will get the product. So if you want to fasten your reaction, take catalyst in the powdered form, right? So more adsorption can take place. That's the reason why you take catalyst in the form of powder. So more surface area, more reaction can happen, more product will be formed. सबको बात समझ आई? ठीक है? हाँ जी. Catalyst, we also have negative catalyst. Poison is also there, but generally when I talk about catalyst, it is understood that I am talking about a positive catalyst. ठीक है? All right. Liquefaction of the gas. The gases which have high TC value, critical temperature, are easily adsorbed. Liquefaction of a gas, I tell you what does it mean. The gases which are having higher critical temperatures are more easily adsorbed. What does it mean? What is TC? 11th class. Do you recall your 11th class? Do you remember it? TC is equal to 8A by 27 RB, where A accounts for intermolecular forces. A accounts for intermolecular forces. If TC is more, A is more, means in the gas there are many intermolecular forces, right? And I told you, surface has only inward force. It wants to pull the gas, it wants to attract the gas at the surface, right? The surface is pulling an inward force, and if your gas is also having intermolecular forces, it is easier for that particular gas to get adsorbed. So higher the TC value, higher would be the liquefaction, or higher would be the tendency to get adsorbed at the surface. क्या मैं अपनी बात समझा पाया? If you want a particular gas to get deposited, or to get deposited at the surface, just what you do, make sure the gas has higher critical temperature. Higher the TC, higher would be the intermolecular forces. The gas can easily sit at the surface. सबको मेरी बात समझ आ गई? सबको क्लियर हो गया? सबको क्लियर हुआ बेटा? So यही चीज है. If TC increases, then आपका A will also increase. If A will increase, this causes liquefaction of gas. अच्छा, one more point. Now I told, if intermolecular forces are more, boys and girls, the gas particles are closer, so it is very easy to to make the gas come into liquid state. That is called liquefaction of gas. So if critical temperature is high, A value is high, intermolecular forces are very high, gas can be easily liquefied. So gases which are easily liquefiable, those gases will be easily adsorbed at the surface. सबको समझ आ गया? B is also a van der Waals gas constant. B accounts for size of the particle, size of the gas particle, but A accounts for intermolecular forces between the gas particle. ठीक है? B is van der Waals gas constant. B accounts for size. A accounts for intermolecular forces. ठीक है जी बच्चों, समझ आ रहा है, क्लियर हो रहा है, मजा आ रहा है अब तक? एड्सॉर्प्शन कैसा है? एक सरफेस फिनोमिनन है, इट इज अ सरफेस फिनोमिनन, एंड if you will take catalyst, if you take the reaction in a powdered form, more product would be formed, more adsorption will happen. Catalyst, that's why are taken in powdered form. If you want a gas to get deposited at the surface, take that particular gas which has higher TC value or which is having higher liquefaction values. ठीक है? The gases which can be easily liquefied, I should say like that, the gases which are easily liquefied can be easily deposited at the surface. बहुत बढ़िया, ये भी क्लियर हो गया. Now these 2 points very important. I will connect them within 5-10 minutes, so pay full attention. Pressure of a gas, how adsorption depends upon pressure of a gas, how adsorption depends upon the temperature of the gas. I'll talk about these 2 points in a very elaborate manner, so pay full attention. Do not go anywhere, pay full attention. देखो, so thermodynamics of adsorption, if I talk about now, that temperature and pressure factor I'll take in 2 minutes, pay full attention. This is also very important. JEE has asked questions on it many a times. JEE ने बहुत सवाल पूछे और कितने आसान सवाल है, you will be amazed. Boys and girls, adsorption, right now wherever you are sitting, look at your wall. Here also gas is coming and getting stuck at the surface, and there is also adsorption happening, right? So adsorption happens automatically. You need not to do anything. So any process in chemistry happens by itself. You call that process as spontaneous. So here, this process is spontaneous, means delta G is negative. Means whenever I will talk about adsorption, you will say, sir, Gibbs free energy is negative. It is a spontaneous process. Point number 1. ठीक है? Point number 2, pay full attention. ये जरा important point है, जरा ध्यान देना. Pay full attention. If I talk about a substance and there are some gas particles, gas molecules, right? Right now, gas is not stuck at the surface, it is free. So here randomness is more. Once this gas will get stuck to the surface of this substance, right? Randomness decreases. If randomness decreases, boys and girls, means what is happening? Entropy, change in entropy would be negative. What is entropy after all? Entropy is nothing but entropy, right? Entropy is nothing but what? It is the measure of degree of randomness. If randomness will decrease, delta S will become negative, right? That's what I have done. Check this out. Delta S has become negative. I hope it is clear. Randomness कम हो गई, यानी कि in adsorption, randomness is decreasing. Delta S negative. Delta S, change in entropy, is negative. And boys and girls, you know your thermodynamics properly. That delta G is equal to delta H minus T delta S. Rearranging it, delta H will become negative because this is negative. This is negative. This is also negative. Delta S is also negative. Overall negative. It means adsorption is an exothermic process. Let me prove it to you by one more point. I can prove it in another manner as well. Pay full attention. Let me show you my face as well while proving it. Pay full attention. Check this out. Beta, I told Avi just now, you will agree with me. If you agree, let me know. If I talk about a substance and gas molecules are coming and getting stuck, means some partial temporary bonds to must be formed. Temporary bonds are formed. Hi Anna, do you agree? Do you guys agree? Must some temporary bond must be formed? Yes or no? Let me know. Chat box is open. It is always open. Hanji, weak forces. Yes, Lokesh, you are damn right. You are absolutely right. Temporary bonds are formed. And whenever in chemistry some bond is formed, let it be a temporary bond also. Whenever a bond is formed, energy is released. That's why delta H has to be negative. Always exothermic. Logic समझ आया? whenever in chemistry a bond is formed, you will say that process is, it's getting stability because of this bond, right? So energy would be released. That's why it is delta H is negative, exothermic. Let me put emphasis on this point. Yeah, fair enough. Moving on. Yes, वेन द वॉल फोर्सेस का बॉन्ड होता है, तो बॉन्ड अभी मैं इसके बारे में बात करूंगा, अभी 2 मिनट रुको, अब बात करूंगा. व्हेन आई टॉक अबाउट एड्सॉर्प्शन नाउ बेटा, इट इज ऑफ 2 टाइप्स. पहला फिजिकल एड्सॉर्प्शन, बड़ा आसान, बड़ा मजेदार, ध्यान से सुनना. Molecules are held by van der Waal forces, weak van der Waal forces. If it is a weak bond, the temporary bond which is formed is not very strong. So the energy required to break that bond is also very less. It is around 20 to 40 kilojoule per mole. और ऐसे समझ लो, the energy which is released when this bond is formed, when this temporary bond is formed with the substance, is very less energy is released. What is that energy released? 20 to 40 kilojoule per mole, which is called as energy of adsorption. When this adsorption happened, energy released was quite less. I hope it is clear. सबको समझ आ रहा है? क्या मेरी बात समझ आ रही है? Now how's the camera quality coming out? I just installed a new webcam. ठीक है? Are you liking the camera quality as well? समझ आ रहा है? Clear हो रहा है? Some of you complain, sir, camera quality is way too low. So I just added one. Super. All right. Now, next point. It is non-specific. It means it is like it is open to all. Substance is saying that all the gases, whichever gas you are, you can come and sit at me. Nothing. You can sit on me, I should say like that. I have no issues. Any gas can be adsorbed because what kind of bond is there? Van der Waal forces, and van der Waal force seek no differentiation. It does not differentiate. So any gas can come and sit at the surface. That's it. Now, what will happen? What do you mean by multi-molecular layer? Once the surface gets deposited by the gas particle, another layer can come and sit on the top. Another layer can sit on the top. It can happen 2, 3, 4 layers can come up. Okay? So multi-molecular layers can happen because what is the virtue of this bond? Van der Waal forces, very weak forces. ठीक है? I hope it is clear. सबको crisp समझ आ रहा है. What is the last point? It is reversible in nature. What does it mean? Let me know. It is reversible. Let me tell you. Right? Reversible is when something is getting deposited or getting stuck at the surface. That same thing can go away also. In your day-to-day life, the gas gets stuck to the walls, right? And that the gas can also deadsorb. There is a word called deadsorption. Whatever the adsorption happened, just when the gas will go out from there, it is called as deadsorption. So whatever, let's say I have a wall, 10 gram of gas got deposited at the surface or got stuck at the surface. When the 11th gram would come, right? Let's say when the 1 more gram would come, 11th gram would come, that 11th gram would go off simultaneously. Desorption is also taking place. या फिर 10 ग्राम आया, 10 ग्राम चला गया, राइट? एक लेवल तक आएगा, इट विल रीच वन लेवल. After that, it will reach equilibrium, right? It will become reversible in nature. Whatever is coming can also go, right? And since these are weak bonds, so automatically they get stuck and it can also go out. The process is called as desorption. You can see in this animated image. समझ आया? Desorption समझ आ गया? ये ज़्यादा अच्छा समझा दिया, मुझसे भी ज़्यादा अच्छा इसने समझा दिया. Correct? All right, awesome. बढ़िया. Now, effect of pressure of gas in physical adsorption. Right now we are talking about physical adsorption. अच्छा, in books, physical adsorption is also called as physisorption. So do not get confused. ठीक है? ये थोड़ा गलत सा गंदा सा हो गया, इसको इग्नोर करना. देखो बेटा, adsorption increases with pressure. Now let me tell you. You tell me. This is not Frenelics. This is not Frenelics locus. Do not confuse my audience by saying something which I am not saying. So do not do that, please. है ना? तो pay full attention. तो my sailors, pay full attention. बहुत इंपॉर्टेंट चीज़ है, ज़रा ध्यान से सुनना. बहुत अमेजिंग चीज़ है. इस पे मैं सवाल पूछूंगा और आपको पूछूंगा, आंसर दो in the chat box. ठीक है? मैं जब होमवर्क दूंगा, you have to answer. So pay full attention. ये आ गया कार्तिक अब ओपी करने. आजकल कुछ बच्चे आए हैं क्लास में, ओपी क्यों कर रहे हो? मुझे समझ नहीं आ रहा है. क्या हो गया है? समथिंग इज रॉन्ग बेटा। अब मेरी बात सुनो। कार्तिक शुरू हो गया ओपी ओपी लिखना। ऑलराइट, अब मेरी बात सुनना, सब ध्यान देंगे, फुल फुल अटेंशन। एड्सॉर्प्शन इंक्रीजेज विद प्रेशर। ठीक है, मैंने ये लाइन लिखी है, क्यों? लेट मी टेल यू। नाउ यू टेल, इमेजिन देयर इज अ वॉल. You guys know PV is equal to nRT. Pressure is directly proportional to number of moles, right? If I throw a gas which is having 10 moles, let's say in a gas, in a particular gas there are 10 moles, right? Same gas, if I throw 100 moles of it, where adsorption would be more? I am throwing some gas at a particular wall. First time I am throwing 10 moles, the probability of getting that particular mole stuck at the wall is less, right? So if I increase the number of moles, automatically the probability of that particular gas sitting at the surface of the wall would automatically increase, right? So that's the point. When you will increase the pressure, you're actually increasing the number of moles of gas, because PV is equal to nRT. PV is equal to nRT. From here I can say pressure is directly proportional to number of moles, right? So जैसे जैसे moles बढ़ाओगे, if I would put more moles, if I take a gas in which I am increasing the pressure by increasing the number of moles of gas, so the probability of that particular gas getting stuck at the surface would automatically increase. सबको समझ आया? So you can see the amount of x by m is what? Extent of adsorption. The amount of gas getting deposited at the surface of the adsorbent will automatically increase if I will increase the pressure. सबको समझ आ रहा है? सबको क्लियर हो रहा है? समझ आया? Next one is effect of temperature. Next one is effect of temperature. Pay full attention. Beta, did I tell you in physical adsorption, temporary bonds are formed. Temporary bonds are formed, right? Some bonds are formed which are temporary, right? But beta, bonds are formed nevertheless. If you will start heating that particular system, they will start, and these bonds are not very strong. They will get energy and these bonds will start detaching themselves. Desorption will start taking place. As a result, rate of adsorption will decrease. Are you able to understand the point? सबको समझ आ रहा है? ये किसकी बातें चल रही हैं? Again, this I am talking about physical adsorption. ठीक है? Good evening. सबको समझ आ रहा है बच्चा? क्लियर हो रहा है? This I am talking about physical adsorption. ये physical adsorption की बात चल रही है. बढ़िया बढ़िया. अब आ गए हम केमिकल एड्सॉर्प्शन पे. बेटा, केमिकल एड्सॉर्प्शन और केमिसॉर्प्शन आर सेम थिंग. ठीक है, दे बोथ आर सेम. Chemical adsorption, from the name itself is clear, there is a formation of a chemical bond, and whenever there is a formation of chemical bond, the amount of energy released would be massive, because it's a strong bond. Chemical bonds are strong bonds, so the energy which is released when the bond is formed is around 80 to 240 kilojoule. You will remember this, right? Chemical bonds are formed with a particular reagent only. Whenever you have a chemical reaction, you know, a particular reactant reacts with a particular reactant to give you a particular product. ऐसे तो हवा में कुछ नहीं हो जाता वहाँ पर. Simple, fair enough. So chemical bonds, chemical reactions are specific. It means chemisorption will also be specific. A particular type of gas will only adsorb or will get stuck at the surface or will adhere to the surface. Are you getting it? Particular type of substance will get stuck at the surface, not all. So it is very selective. It is very selective, right? That's why simple monomolecular layer is formed. A single layer is formed on the surface. Once the area is complete, no more chemical absorption, chemisorption or chemical adsorption. ठीक है? मतलब you have to, this is one molecule, ठीक है? This is one molecule. One layer will come. अच्छा, in some texts, if you read more about it, you will find once chemical adsorption is done, there is a probability that physical adsorption can come. In chemical adsorption, they will show another layer. Na? This layer is coming because of physical adsorption, not of chemical adsorption, not because of chemical adsorption. If you see a chemical adsorption and you see on, this is experimental. I'm telling you an experimental fact. Sometimes in chemisorption also you see some second or third layer. Actually, it is not because of chemisorption. It is because of physical adsorption. Physical adsorption can happen anywhere because of van der Waals forces. But chemical bonds, chemisorption is specific. That I will take a particular gas. I will allow this gas only to come and sit at the surface. I hope the point is clear. सबको समझ आया है? सबको clear हुआ है? बढ़िया, बहुत बढ़िया. In here only one layer. Acha, you tell me one more point. If the layer is formed, and layer is formed because of the chemical bond, would it be easier to break the bond? Because the bond is formed due by the virtue of a chemical reaction or a chemical bond, right? It will be difficult to break the bond. That's why it is irreversible in nature. You do not see desorption happening here. You do not see desorption happening here. Once the bond is formed, done. Chemisorption is over. You will not see desorption. Okay? All right, beautiful. Now let us understand more about chemisorption. I told you effect of pressure of gas I will talk about. Now I am talking in terms of chemisorption. Now pay full attention, boys and girls. If more is the pressure, more is the probability of the gas to come and sit at the surface, right? Wow, I did a blunder here, 1 second. Teeny tiny blunder, not a big blunder. All right. हाँ जी, ध्यान देना, pay full attention. I want my gas to get adsorbed at the surface of a particular adsorbent, right? So if I am increasing the pressure, beta, first of all it will increase. Then it will become constant. Can anyone state me why it is becoming constant? First it will increase, then it will become constant. कोई मुझे बताएगा कि ये constant क्यों हो रहा है? Would anyone like to come forward for it? बहुत बढ़िया लोकेश यार, आज तू मेरा दिल जीत रहा है लोकेश. इधर क्या चीज हो रही है बेटा? There is only one layer formation. After one layer is formed, surface is no longer available. अरे जब surface है ही नहीं तो chemisorption कैसे होगा? There is no surface available for the adsorption, so there would not be any kind of adsorption. So no adsorption, not equilibrium, no Vijay. You don't have any more surface left for adsorption, so how can you say adsorption will take place? That's why it is becoming single, the graph is becoming constant after a while. Hope it is clear. I hope it makes sense and you are understanding. Clear? बहुत बढ़िया. आगे बढ़ रहा हूँ. Next, so this is effect of pressure of gas on when we talk about chemisorption, right? Next, effect of temperature. This is beautiful, yeah. This is actually quite interesting. Check this out. Chemical bonds are formed because of the attraction, right? Because of the let me tell you. Let me put it like this. Chemical bonds are formed. For a chemical reaction, you require some energy. Activation energy for a particular chemical reaction to happen. When you heat some particular reaction, what will happen? The chemical reaction can take place easily. You are giving that activation energy, and the reaction can give products, right? So initially, when you increase the temperature, you are causing your reactants to react with each other and give product. So as a result, more amount of gas can easily get adsorbed. That's the funda here. There is a bond formation between gas and the adsorbent, and that bond is chemical bond. So when you heat this process, this chemical bond formation becomes easier. But if you keep on heating it, whatever the bond which is formed, a chemical bond, and any bond can be broken, right? This is a chemical bond, strong bond. But if you keep on increasing the temperature, even this is susceptible for, so it will be broken easily. It will be broken easily if you keep on increasing the temperature. That's why first it increases, you're giving the activation, then it decreases. ठीक है? सबको समझ आया? सबको क्लियर हुआ? ये ग्राफ का समझ आया बेटा? Effect of temperature in chemisorption. Again I am talking about in terms of chemisorption. ये सब chemisorption का है. तो जो मैंने बोला था, I told you that I will link effect of temperature and effect of pressure. I have linked it with physisorption and chemisorption separately. ठीक है? It gives you more wider idea. Clear है? आ गया समझ? Let me know sailors. अब मैं सवाल पूछने वाला हूँ. I'm gonna ask you some questions. बहुत बढ़िया. ठीक है. So my question number 1. If I talk about physical absorption, physisorption or physical adsorption, I have given here some temperature. T3, T2, T1. These are called as isotherms. The graph made at constant temperatures different graphs I am making, keeping temperature constant. These graphs are called as isotherms, right? Can you tell me what will be the order of this temperature, where the adsorption would be maximum? Let me know what is the answer. Let me know what is the answer, boys and girls. What is the, arrange the temperature in decreasing order. According to you, where adsorption would be maximum, at which particular temperature adsorption would be maximum? Very good. Taranmeet has given the answer. T1, T2, T3, absolutely right. Because in physical adsorption, if you will increase temperature, adsorption decreases because the bond starts breaking. The bond starts breaking. So T1 temperature, since T1 is very less than T2, T2 is less than T3. So this is the adsorption order. This is the adsorption order. When the temperature is T1, adsorption would be maximum. I hope it is clear. And when temperature is T3, adsorption would be minimum. Clear हुआ बेटा? ये ग्राफ कंफ्यूज करने को दिया है. याद रखना, जब टेम्परेचर ज्यादा होगा तो एड्सॉर्प्शन कम होगी. इफ आई टॉक अबाउट फिजिकल एड्सॉर्प्शन. क्लियर? क्लियर है? T1 will have the maximum adsorption. I hope it made sense. सबको क्लियर हो गया है, सबको समझ आ गया है. Because in physical adsorption, if temperature would be increased, the adsorption would decrease. So T1, since it is the lowest, adsorption would be maximum. Beautiful. Next question, I am going to give you a homework. I am giving you idea. Chemisorptions. In chemisorption, if I talk about a low range temperature, means I am not increasing the temperature drastically. Initially, whatever the temperature requirement is there for a particular chemical reaction to happen, that particular temperature I am giving. Okay. Now you remember in chemisorption, if I increase temperature, adsorption also increases. So the temperature order is T3 is more than T2, T2 is more than T1. Can you tell me where adsorption would be maximum in the comment down below? You know, you have to give your answer in the comment box after this video is over, after this session is over. This is the last, homework to you. Last slide I am on. So you have to give me adsorption order. You have to give me adsorption order. Key in which particular case the adsorption would be maximum. In which particular temperature case the adsorption would be maximum. Drop your answer in the comment box after this session gets homework. This is my homework to you, and with this I have to say goodbye. And yes, I have finished the first lecture about adsorption and adsorption, and I have given a good differentiation. Similarly, boys and girls, I will like to tell you here that we are conducting week quizzes, right? Join the app. Link is in the description again. Download the app if you haven't. We are giving some cash prize as well. If you will win the quiz, you will get some cash prize, Paytm prize as well. So do check it out. It's for free. What's the harm? Similarly, again, I like to tell you, if you are weak at a particular topic, whether it is in chemistry, whether it is in physics or maths, do check out the micro courses. You can learn a particular topic, particular chapter from any subject just by paying 1 rupee, right? So what are you waiting for? Enroll now. Link is in the description box again. Okay? Similarly, I have my playlist ready. If you are following me everyday sailors, make sure, and if you are not, if you are coming here for the very first time, I have a playlist which is also down in the description. Every chapter I have talked about since, of all of your 12th standard, I have talked about them. So make sure you check it out. ठीक है, आपकी अच्छी रिवीजन हो जाएगी, अच्छी प्रिपरेशन हो जाएगा, बढ़िया. And yes, download the app, Telegram app, because we are giving you assignments. We are always posting stuff. We are telling you what is to be done. We are asking you what you want, so you can be an active member there and help you. We will help you. You will help us. It's a beautiful platform. Join the channel again. Link is in the description box. Okay? And boys and girls, if you have loved the video, I loved it today. If you have loved it, please like the video right now, share it, and subscribe to our channel if you are watching it for the very first time. Okay? Thank you so much. It was pleasure serving you all. That's it for me today. See you next time. Bye-bye.